Hi, my name's Chris. And my name's Chris. Welcome back to my shop. Hey, I thought it was my shop. Welcome back to
Okay, it's our shop.
In this video, I'm going to talk a little bit about table saw safety, and I'm going to demonstrate some of the fundamentals to get you started using a table saw safely. If you're interested in that, stick around. The table saw is one of the most capable machines in the modern woodworking shop. It's at the heart of most processes, whether from cutting boards to cabinets. It's often a machine that someone purchases when they decide to get serious about power tool woodworking. It consists of a 10-inch or 250mm blade that rotates between 3,000 and 5,000 RPMs. This blade is designed to rapidly and cleanly cut through very thick and hard wood materials. The large rotating blade and the frequency of use that it gets in most shops all contribute to the fact that it's got a reputation as one of the most dangerous machines in the shop. It's important to establish a solid foundation of fundamentals to use the machine safely. According to the National Institute of Health, in the US there are over 30,000 table saw accidents a year that cost about $2 billion in medical bills. That's absurd. And keep in mind, those are only the reported accidents, probably involving a trip to the emergency room. Whether you're brand new to woodworking or experienced, knowing the capabilities of the machine is exactly what's required to operate it safely. You need to respect the machine and not be afraid of it. Respect comes through understanding. When you learn what the machine is and isn't capable of and what's safe and not safe to do, it helps you to plan your cuts and plan your projects, ultimately making you a better woodworker. If you practice the fundamentals routinely, your respect and understanding of the saw and its capabilities will grow over time, and you won't become complacent. I find it healthy to refresh on the fundamentals by way of reading current magazines, books, or if you're experienced, taking on a new woodworker and forcing yourself to teach them the fundamentals of shop safety can all keep you fresh. Please keep in mind that each of the table saw setups have their own intricacies and specifics for safely setting it up and using it. So a lot of things won't be covered in this video, but if you have a specific question, please throw that down in the comments below and help somebody else. Before getting started, you need to make sure that you've learned the parts and all of the adjustment of your table saw. I strongly encourage you to go take a local class that's offered in your area. A lot of schools, maker spaces, or even the local woodworking store will offer courses on basic shop skills and safety. But make sure that you learn the parts of your saw before you begin to use it. This can come from reading the manual, looking at adjusting the saw. Make sure that you always disconnect power anytime you're working in and around the throw plate or the blade. If you haven't already, I have a video that reviews the parts of the table saw for you to go check out. The link's down below. Make sure you wear safety glasses and hearing protection for every cut. There's a lot of times I'll find myself even doing a household chore and I'll come out to the garage to cut something to length really quick on the miter saw or rip something down really quickly on the table saw. You want to wear hearing protection and eye protection for every single cut, because undoubtedly Murphy's Law, the one where you don't, is the one where you're going to get something in your eye. And keep in mind that hearing loss is actually cumulative. Having known more than one woodworker with tinnitus or hearing loss and starting to develop tinnitus myself, I know that you want to wear hearing protection anytime you're around a loud noise. Make sure that there's no gear on the floor, on the tabletop, or debris around you to work around. My entire floor here and my work area is completely clean and free of clutter. Make sure you remove your rings, bracelets, tie back long hair, roll up your sleeves, etc. Anything that can get caught on not only the blade, although it would likely cut through things like that, but also the fence or the material. You don't want to be able to get caught on anything while you're working with the saw. All right, let's talk about some general rules and body positions. You always want to stand to one side of the blade. As a right-handed woodworker, I typically stand slightly to the left of the blade. Really, you can use the miter slots as your caution area, but the most dangerous place to be is between the blade and the rip fence whenever you're conducting ripping, or directly in line with that blade. Not only does standing on one side help you avoid bad position, but it also keeps the sawdust that inevitably comes off the saw blade from hitting you in the face. Keep the area behind the saw clear. In this case, I have a garage door behind me, but you want to make sure that if you are in a crowded workspace, that there's nobody behind where you're working on the saw. Staying off to the side also helps keep your forces into the fence as you push through the blade. And also keep in mind, you never for any reason want to reach over the blade or behind the blade or up to the blade when it's in operation. This is where keeping a guard on the saw at all times really helps you prevent accidents. You will from time to time in my videos, whether for clarity or for a specific operation, see me take my guard off, but what you'll rarely see come off the saw is the riving knife, which we'll get into more of that a little bit later. Keep accessories that you're going to need throughout the course of the cuts right next to the saw. When you give everything a place, it's easy to put it back in that place and develop the muscle memory that you need to go for that safety accessory rather than doing something that's risky. Better to have it there and not need it, or have it and use it for a specific reason, than to go hunting around the shop whenever you need something, or avoid using it because you can't find it. Always remember that as this blade rotates, the rear of the blade is the danger area. It is rising and the front of the blade is falling, which means that the front of the blade tends to hold the workpiece down to the surface, and the rear of the blade tends to want to lift the workpiece when the teeth can get under it and pull it back up off the table or into itself and back over. For every single cut, make sure you adjust the blade height. When I was coming up, I was told to raise the tip of the blade 1/4 of an inch through the workpiece and no higher. Now, I've recently learned that the actual correct height adjustment for any blade is to raise it until the bottom of the gullets are clear with the top of the workpiece. This gets the teeth in the proper rake angle that the blade was designed for, and may be slightly different for each blade. What I have also noticed though, is that leaves the teeth only exposed about 1/4 of an inch. So most blade manufacturers factor that in. A table saw blade spinning 4,000 RPMs has an equivalent linear speed of 176 feet per second, or 53 meters per second. That means it has the ability, if it was securely attached to an object, to move it at those speeds. That is way faster than you can react to. You're talking milliseconds if something gets caught in the blade and thrown. Also, as it's pulling your hand along, if you're holding the workpiece, your hand can be pulled into the blade faster than you can react to it. And for the baseball players out there, that linear speed is 118 miles per hour, which is way faster than a professional baseball pitcher's fastball. Obviously, nobody's going to intentionally cut their finger or put it into the blade. However, I do personally know people that have been injured on the table saw that either had years of experience or had a moment where they weren't thinking. The purpose of the guard is it's a physical barrier that at the very least will prevent you from accidentally contacting the blade. Not to mention, if there's ever an instance of kickback where your hand is accidentally drawn into the blade, it will prevent you from making contact with that blade. So the bottom line is you want to keep the guard on for any operation that you absolutely don't have to remove it for. The best types of guards will also prevent chips and dust from coming back at you as the operator. Most modern guards are actually very user-friendly and adjustable, whether you need to get them out of the way for a measurement or remove certain parts of them for operations you don't need them for. And a lot of guards nowadays have integrated dust collection to keep some of that finer dust and the chips from coming back at you. As you go through the setup of your cut, plan and visualize what's going to occur during the cut. Even rehearse it if you need to. With large sheet goods, quite often, when I'm forced to cut them by myself or break them down by myself, I will actually rehearse it by lowering the blade all the way under the table, placing the sheet good where it's going to be in its final position for the cut, and making sure that it's adequately supported on all sides so that it's not going to fall on me or do something that I don't expect through the course of the cut. But the bottom line, when it comes to putting yourself in an awkward position, if you mentally rehearse it, you'll see this bad situation and you'll think of a better, safer way to do it. For long cuts, whether rip cuts or cross cuts, make sure that you have your work properly supported. This outfeed table is great, especially whenever you have to work by yourself, because it fully supports the offcut as it falls away from the blade and the saw. But make sure that you use roller stands or have a buddy to receive and support the outfeed material. Keep in mind that the person, if you are ever working as a team, the person behind the saw is the operator and they are the one controlling the workpiece. Any assistant is simply there to support the workpiece passively and not move it side to side, which can force it out of alignment with the fence or into the blade in an unsafe way, or a way that's going to cause marks or poor cut quality. You want to go through a mental checklist all the way from getting your workpieces wherever you're going to stage it at, to turning on the saw, to where your hand positions are going to be throughout the cut, what safety accessories you're going to need, and where you're going to finish the cut, to turning off the saw. Mentally rehearsing that can help you identify if there's any awkward body positions or anything potentially unsafe that you're going to do, or any safety accessories you might need for the cut. Never chase a board, an offcut, or a workpiece over the saw. Push it all the way through the cut and let it fall away. Better yet, find a way to support it all the way so that you don't have any pieces diving away or falling off the side of the saw when the cut completes. You want everything to be as predictable as possible. That gets into give the saw your undivided attention. Never consume alcohol and operate a table saw. You're just asking for trouble. Never work in a distracted environment. And make sure that anyone in your family or anyone around you knows not to distract you when you're using the saw. Finish the cut, turn off the saw, get rid of the ear protection, and then have your conversation. But when you're focusing on a cut, be fully engaged with the machine and your body and how you're working with the machine the entire time. As more and more people get into woodworking, they often start with dimensional lumber or recovered woods, like this pallet, for their projects. This is a great cost savings way, and a lot of people desire those type of things. But I just want to caution you and make sure that you always have two square edges, a flat base and a square edge to reference on the fence when ripping materials on the table saw. This pallet has quite a bit of cup in it. It's probably hard to see on camera. So if you do find yourself needing to use dimensional lumber for a project, make sure that you're very meticulous in selecting it. Select boards that don't have any cup or twist or bow, and keep in mind that these aren't dried to the same dryness that good quality prepared lumber is. You want to make sure that you want to make sure that your piece has at least two milled surfaces on it. Generally a straight edge for referencing on the fence and a flattened face. Everything else can be in the rough state, but as long as you have two square flat edges to reference, you're generally good. So this piece of 8/4 cherry has a very rough edge here, but it's been planed top and bottom and it has a jointed edge. So this could safely be run through the table saw. Never run round pieces through the saw on their own. You can see how easily this just rolls around. It'd be unsafe to put something round through the table saw. There are ways to cut round things, but it's really outside the scope of this video. You'd have to clamp it to something that's flat and square as a jig to run it through the saw. Keep in mind that wood is a natural material. It changes over time. It can even change through the cut. There's natural stresses in it. You can see this split or this large check on this piece of walnut because this came out of the pith of the tree. Right there's the absolute center of that tree. And you can see just how badly it checked. This can even happen during a cut. A cut can splay apart or even rive back together just due to stresses being released in the wood and it wanting to twist or do whatever it needs to do to release those stresses. Generally don't cut things shorter than 10 or 12 inches through the table saw, or I think that's about 300 millimeters because they have a tendency to rotate. This is just unsafe, and this thing's more likely to become a projectile than to get a quality cut. If you do need to cut something short like this, either to width or to length on the table saw, we'll talk about some options in a little bit later in the video. Next, we're going to go over some rules for ripping or cutting a board to width with the grain of the material. Always make sure you have a push stick or push block handy when ripping. So my fence is currently set at 6 inches. So a good rule to follow is if you're cutting 6 inches or narrower, you're going to want to use a push block or push stick for that cut. As you can see with my hand here, your hand starts to get over the throat plate and very close to the blade as you're feeding your material. A good trick that I learned a long time ago is to hook my pinky on the fence. And if I'm able to reach into the area of the saw blade or over the throat plate, then I know I need to be using a push stick for that cut to keep my hands up and away from that area. So just as an example, this board is wider than 6 inches, so I can safely feed this through without a push stick. Let's talk about the directions of pressure. So there are 3 directions of pressure whenever you're making a cut. One is into the fence, keeping that square reference edge up against the fence, which is going to give you a consistent width. Keeping the flat piece, the flattened edge, down to the table, and then feeding it forward through the cut. So you can see that the body position we talked about earlier helps me achieve that. So having my body off to the side allows me to push pressure into the fence keeping my hand on the back of the workpiece or on the top like this. And then if I hook my finger, I can feed that cut all the way through safely, back clear of the edge of the workpiece, and then shut off the saw. For long pieces and pieces narrower than 6 inches, it's very similar, although you feed straight through. I keep pressure with my left hand into the fence and down with my thumb. And I never let my hands, once my hands get onto the table, then I know that's where I need to transition to a push stick. So I just push pressure in, hand over hand, keeping your pressure, either hand over hand or set this up with constant pressure here. Be careful of splinters. And then I know that once the rear of my workpiece gets transitioned to the table, I want to go back to that push stick or push block and finish the cut, keeping my hand 5 or 6 inches away from the blade. Now, let's talk about pressure. We've already talked about pieces wanting to rotate into the blade. One way that you can ensure that this doesn't happen is whatever type of push stick you use, keep it close to that guard or close into your blade. What that does is for narrow pieces, it forces you, as you apply force forward, it's going to actually cause that piece to rotate and keep it tight against the fence, rather than if you were to push up against the fence, any rotation that you're imparting on that is actually pushing the workpiece toward the blade, which is the opposite. We want to push out here and cause it to want to rotate as it's contacting the blade, rather than if you push close to the fence, you push it into the saw blade. So 6 inches is the minimum rip width that we're going to go with for not using a push stick in this video. I have seen it briefed as close as 4 inches, but I think that that's a bad rule, because at 4 inches you can reach the blade with a normal hand size, and so I just think that that's bad practice. So the rule that you should follow is 6 inches, and that's it. That's a great rule that's going to keep you safe forever. All right, let's talk for a minute about cutting thin pieces. You can see I've cut these thin pieces for some cutting boards. I started out with a nice thick piece of stock like this, and I cut these slivers off. Never cut thin pieces like this in between the fence and the saw blade. You're just asking to turn one of these things into a missile, sending it back behind you at a rapid rate of speed. So you always want to index your fence over and allow these small pieces as the offcut to just fall away from the blade. Not only does this keep it from becoming a projectile, but it also allows for some good cut quality too. All right, so next we're going to go ahead and demonstrate exactly what we just talked about. So I've got a piece of wood here. I've got a jointed edge, and I've got 2 parallel faces because it's been planed. This board is 6 7/8 wide. I'm just going to bring it down to 6 3/4, and I'm going to take a fine cut off the side of it. I'm going to check my blade height here. So I've got that bottom of that gullet right flush with the top of this board. I'll go ahead and put my guard back in place. So I'm going to do a little bit of a mental rehearsal and an actual rehearsal. So I'm going to start out here, and I'm going to keep my 3 directions of pressure. I'm going to have down and in with my left hand until I get into the edge of the fence, and then I'm going to walk that hand back and continue to feed it. This hand's going to control the back rear of the board. I'm keeping my pressure in the fence, forward, and down to the table. By hooking my hand, you can see that I can push completely clear of the blade. I'll go ahead and demonstrate this cut freehand because I've got plenty of space here between, it is wider than 6 inches, and I'm just going to push it all the way through, making sure I'm not coming over top of the blade at any point in time. And of course, the area between the fence and the blade are clear. I've also got my anti-kickback paws and riving knife in place, and of course my guard's in position. So let's go ahead and make that cut. Dust collection's good to go. We let the blade come to a complete stop, and you see I didn't even attempt to go after that offcut. Boy, that sassafras smells amazing. I really like the smell of that wood. Haven't really done much work with sassafras, but I got a few odds and ends that I'm gonna potentially make something out of. Okay, so now we'll demonstrate a long cut. This board is currently 3 inches wide. We'll say we're making a 2-inch face frame. So I'm just gonna come in here, adjust my fence to 2 inches for that face frame. And you can see there's definitely not space for my hand in here. And if I were to put my hand in there, I'm putting it at risk. But you can see the guard keeps the blade completely encapsulated. I got my riving knife. We'll deep dive kickback in a little bit. And of course I got the anti-kickback pawl. So this board has been, I think, jointed on this edge, and it's got parallel faces, so it's nice and square. I like to use push blocks when I can, but a push stick is also good, especially for these tight-in operations. Anyhow, we'll go ahead and do the same thing. We'll check our blade height, make sure we got it right. It's up a little high for this. It's just 3/4 inch stock. We'll go ahead and make that cut. Ears and eyes always. Once again, we let the saw spin down. Don't go after that offcut. You always control the workpiece all the way through the cut. Don't worry about the offcut. Okay, saw stopped. You know, and I will say I probably violate the retrieval thing from time to time, but always make sure that your pressure is forward and away from the blade, not into the blade at all, and don't reach with your fingers. Probably a rule you've probably seen me violated on camera. Okay, let's go ahead and just say we're continuing on with our face frame. So we're gonna cross cut it to length now. So the first thing we're gonna do is get the rip fence out of the way. You don't want it to be anywhere near the tabletop when you're cross cutting. Most right-handed operators are gonna wanna primarily cross cut in the left-hand miter slot. But you'll see whenever we do beveled cuts, where the blade on my machine is gonna angle that way, you primarily want to work on the side where the blade bevels away from your hand. So I'm going to switch over to the right hand miter slot whenever we do any miters or beveled cuts. So we've already got our blade height set up here. Go ahead and get the miter gauge out. We can check it for 90. But really for demonstration, it doesn't matter what width it's going to be. Now, if I wanted to square up the end of this stock, you can see it's hanging off the table all the way. I would obviously need to provide some kind of support all the way from behind the blade where my cut's going to start to all the way forward, so that once the cut's complete, I don't have to worry about chasing a board that's falling away, that it's completely stabilized here, self-supported, and I can just lift my hands up, turn off the saw, let everything stop, and then retrieve my piece and go back to set 0. But in this case, we're just going to pretend like we're starting in the middle of our board. I'm going to keep my hands here. I'm going to basically pinch it back to the fence on the miter gauge, and I'm just going to feed it through, keeping both hands to the side of the saw. And I'm just going to let that offcut sit there. I'm going to control this piece because this is the piece that's actually going to be part of my project that I'm going to keep. And this is waste as far as I'm concerned. So there may be a little tiny finger of a splinter that stays on this piece just because this one's going to come all the way through the saw, and this may partially shear off here at the very end. Eyes and ears always. And just like before, we're gonna let the blade spool all the way down. And then we're gonna retrieve our offcut. Now, like we talked about, sometimes I'm gonna get these anti-kickback pawls out of the way because they're not really necessary in this instance. All right, so I've got my face frame that I wanna cut here again. Okay, and I want all my pieces to be 12 inches long, so I'm just gonna go ahead and set my fence to be 12 inches long. I'm gonna go ahead and get my miter gauge out here. Never do this, okay? Never use your miter gauge and your rip fence at the same time. Let me show you why. Well, there's two reasons here. Number one, there's not really a good place to get this in here. Second of all, if you use this as a stop, let's bring it out here, maybe you can see it. As you're putting pressure here, this is gonna constantly be rubbing on that, and it's gonna wanna rotate this piece. And as this piece wants to rotate, guess what's gonna happen? It's gonna engage and wedge into that blade. And when it wedges into that blade, you're gonna eat this piece of wood, okay? So never use a miter gauge and a rip fence. Don't do it. I say that, and now I'm gonna show you a technique of how you can. So, way back here, you can add a stop block, adjust this as a repeatable stop, butt your piece against it, and as long as this piece, when it's being cut, doesn't contact anything over here, it's safe. You're not imparting any rotation, you're just referencing your miter gauge as you would for any cut. So if you need to use a stop block, make sure you always use it far enough back that your workpiece is never going to be in contact with the stop when it's anywhere near the blade. That way you're not imparting any kind of a twist on your workpiece and trying to eat a piece of wood, because wood's not very tasty and human body really doesn't digest it, so you don't want to be eating wood. Anyhow, so this should be a red flag to you anytime you see the rip fence and the miter gauge on the table at the same time. Just get it out of the way, get it off the table. In my case, I've got a spot to stow it right here. So mine just goes off the table. Now there's all kinds of cool things nowadays. They've got magnetic stops that actually you can have an on-off stop right here, and you can just butt it up and make repeatable cuts all day. Some people like to use their table saw for cross-cutting the length, just because they've got really nice table saw blades or whatever, and they prefer to just work at the table saw. But I do most of my cross-cutting on the miter saw. But it's kind of user preference, and it depends on what you're setting up. You know, you may have certain types of frames or what have you, and your table saw is just more repeatable. So anyhow, if you have to make repeated miter cuts, that's a technique. Those are two techniques you can use, the stop on the fence or the Magna block type stop, or you can clamp a board right here, but just make sure that it's short enough that as you're cutting, it's not your workpiece isn't in contact with anything. So I hope those tips help. All right, now, so we're gonna go ahead and bevel the end at 30 degrees. So I'm just gonna go ahead and unlock my trunnion lock here. Tilt my blade, we'll go to 35 degrees. I'm gonna lock it into position. You can see my guard is starting to kind of get funky here. We're gonna make sure that our blade's gonna clear the workpiece, so we're gonna actually bring it up a little bit since it's a beveled cut. Just do a little rehearsal here, make sure nothing's gonna get caught. Everything looks like it's gonna clear with the guard. We can actually put the guard down on this type of guard because the two sides move independently, so it's actually a great guard in that respect. Now I've got a little bit more of the blade exposed here on the side. So when you're making this kind of a cut, this is why you switch over to the right side and you keep your hands on the opposite side that you're beveling the saw blade to. Anyhow, so we've already got our eyes and ears on. We're just gonna go ahead and make that cut. Let everything completely stop and get the guard up here out of the way, and then we'll retrieve our workpiece. I'm burning quite a bit on that. All right, we'll go ahead and return this to 90. And I don't know if you saw, but once I passed through the cut, I started to pull the piece out of the way, but I pushed it all the way through the blade before I moved anything. All right, next we're gonna deep dive kickback, okay? So I'm sure you've heard or seen videos or read in books about kickback and it being one of the most dangerous things when operating a table saw. Really, if you're following the fundamentals that we talked about and you keep your guard and riving knife in position at all times, it is still possible for you to create a situation where there's a kickback, but it's highly unlikely, especially, by the way, I've already unplugged my saw for this, so I will be referencing the blade and showing you some close-up things. So I'm gonna go ahead and remove the guard right now. So my guard is multiple piece. This is the actual, what I'd call the actual guard. You've already seen me take the anti-kickback pawls on and off, which depending on the operation, I don't really use these unless I'm ripping lumber that's less than ideal, because these are an ultimate kind of redundancy. You see that these blades are very sharp. They will wedge into the wood. They can also leave lateral scratches if you go to move a workpiece out. They're spring loaded and they keep downward pressure on the workpiece. So they can scratch the surface, but if I'm, say, ripping a 2x4 dimensional lumber or lumber that's not to its finished surface, then this is fine. But if I'm cutting pieces to final size, a lot of times I won't use that. But anyhow, this device here, especially a riving knife that comes all the way over the center of the blade. So we already talked about there's two parts of the blade. This part forward of center is going down and exerting downward pressure. And this back part, this is actually the part that's gonna come into the workpiece first. So as you're feeding that piece, these are the teeth that are actually engaging with that workpiece first. So they're grabbing little splinters and pulling them down to the table. And then these teeth complete the cut. And then once it's all the way through the top surface, then the new material that's cut is on the top surface here. And then it just continues to cut the rest of the way through. So really these back teeth don't make a whole lot of contact with the wood. Obviously they do as they pass through the kerf. But what can happen is a piece of wood can pinch back on that and it becomes part of the blade for just a second and gets thrown by the blade backwards. Now, whenever you have the fence here, that gives a surface for that board to get pinched in between. And just like a pitching machine for a baseball, it has those two wheels that are constantly spinning, and you just put a ball in there and it shoves it out through like that. It's kind of the same idea. It pinches it between the fence and the blade and just catapults that board back like that. Now it can also pull a board in if those teeth get under a workpiece across the blade and fling it up back at the operator. So people will have gotten hit in the side or even hit anywhere in their front if they're standing right in line with the blade, because that piece can come straight up at you. So this commonly occurs when you're ripping, and it can also occur with sheet goods, especially small, lighter weight sheet goods like Luan. Real world examples there. But anyhow, so getting into the details of a riving knife like this, it covers the center line. So really there's no way for those rear teeth, sure they can get back at it, but it can't get that full leverage and it can't draw that piece in and over the blade and still apply upward pressure to it. So the worst that's gonna happen is you might get some burn marks, but really this device almost completely prevents the ability for this blade to kick back. It can still get pressure in between the blade and the fence, or if you were to shove pressure, it can still grab it by the side, but obviously those teeth aren't able to get under that workpiece like they could if you have it installed. Now, this is a multi-position riving knife. So one of the things I bought this saw for is even for a contractor saw. So this is the full position where you have it at the highest setting and you put your top guard on. But if I need to make not a full through cut, I can keep this in place. So here is a second position. And now my riving knife is even with the top of the blade. So still I am keeping the teeth from getting under that workpiece in the back there in the most dangerous spot, but it can still get on top of the board. But if you're ripping, you can see that it's going to prevent that piece from moving horizontally and getting under that blade. And the nice thing about this is it's slightly lower than the top of the teeth. So as you raise that and lower that blade, you can actually make a non-through cut with this riving knife in position like this. Dados can also be a concern where you've got that wide blade. You still want to try to use a riving knife, even if it's one like this, even though it won't prevent that entire width of the blade from making contact. It'll still prevent that piece from moving over and getting up on top of the blade and being launched. Okay, and then it also has a final position, which is all the way out of the way, and probably dados and a few other cuts are probably the only circumstance where I would want to completely stow this thing out of the way. So really my guard, and this is very similar to how most of them are nowadays, they'll have multiple positions, and so really it's only on your laziness whether or not you're using something like this. So I really have no excuse to not have my riving knife on and at least have the primary safety feature installed on my saw at all times. Because of that, we're going to go ahead and put it back in its full upright position, lock it in place, and I'm just going to bring you in for a side view of what I was just talking about. So here's our workpiece. We're going to adjust it for the correct height. So here you can see with the riving knife in place, this board cannot get up and over that. So if we have the fence here pinching it, it can get a little bit of lateral traction, but not much because it's mostly contacting the side of that blade. Okay, so you can see immediately how it's going to prevent it from pinching on that blade. Now the blade is still slightly wider than this riving knife, but the primary thing it acts as is a stop to keep that board from getting over into that blade. I'm going to go ahead and rotate the blade by hand, and you can see, so here forward of center, all those teeth are going down and through the workpiece, and back here they're rising. So you can see that this, as you push the board through the end of the cut, if you didn't have this in place, it's very easy for that piece to come in and get on top of that board and come back. But since this is here, if it gets any tendency to push in, it butts up against this and keeps it from going up and over that. Now we're going to completely stow this. It's a little tight. I don't want to cut a knuckle on one of those teeth. Now, we're going to completely stow this, and you can see that there's nothing preventing this from getting up and over. If there's any tendency to pinch it. So you can see I'm applying pressure in, and it's picking it up. All I'm going to do is apply pressure in and spin that, and you can see it's raising. And what can happen is it can get up and on that and just shove it. Remember, this is moving, the linear speed of this is 118 miles per hour. So it can just catapult that right back. And where you have lightweight sheet goods, a lot of times what will happen is they'll get caught and they'll come up and over the blade like that and get spun and just come flying up and out. So now you know the fundamental forces involved in kickback, and you know that it's likely if you have any kind of a modern saw that has a riving knife on it, it's got multiple positions, so really they've already removed any excuse you might have for not keeping this in position. And even if your saw is old enough that it doesn't have a riving knife, you can still make a zero clearance insert, but instead of this piece, you can add a splitter, or you could use a piece of aluminum angle and mount it and make a splitter. So really there's no excuse not to have a splitter. The only kickback I've ever personally had was being a knucklehead. I mean, any kickback generally is a result of some poor decision. I had a small offcut that was between the fence and the blade, and I fired a small, probably ½ inch wide sliver of wood behind me. It's since I've built this setup, so I was working outdoors and it actually fired it behind me. I've had near miss with plywood, especially small sheet goods that flex. To where they can bind up in the blade. But luckily I was able to recover that and just stop the saw and didn't have any kind of a kickback. But I have seen sheet goods that have kicked back, and it leaves a telltale pattern on the back of it where the blade gets under and it cuts a kind of a, I guess, a triangular shaped semicircle groove out of the underside of it. My dad has had a sheet good, and I think he saved the piece and hung it on the wall or something to remind him of the kickback that he had cutting sheet goods. I know of, in my dad's shop, he tells a pretty good story of another teacher that came into the shop to use the table saw, and he had a long workpiece. I don't know what he was working on exactly, but he was ripping, and he fired a board, like a 2x4 size board, through a chalkboard. Luckily it was a workshop, so they had no desks or anything behind the work area for the table saw, but there was a chalkboard, and it put the board through the chalkboard. So awful lot of power with kickback. Just some real world examples there. People will often talk about job site table saws versus larger saws with higher load motors. Really, the no load speeds in a job site saw and a cabinet saw are the same. They're between 3,000 and 4,000 RPMs typically. Really, the only difference is the type of motor and the amount of power that that motor can transfer to the blade without losing speed throughout the cut. So what I'm getting at with that is that spinning blade is just as dangerous as any other saw's spinning blade because they're the same speed. It can throw a board back at you or cut through flesh just as quickly as any other type of saw. I've personally been using the table saw for over 20 years, and I found it helpful to review these rules. As I get more serious about producing videos, I won't accept myself demonstrating an unsafe procedure on the saw, knowing that I could very well be teaching somebody that's never used the saw for the first time. Please keep in mind that this is a basic introduction and list of safety rules. I've tried to list out the rules and go over the reasoning behind them to give you a simple and relatively condensed video to get you started safely woodworking, even if you don't have another source out there. There's all kinds of good literature on the internet. A lot of the colleges that have wood shops or even high schools have their wood curriculum published online. I encourage you to go check that out. I've also provided a summary and test for you to check your learning on my website, and there's a link to that in the description. So we hope you enjoyed this video. Excuse me. I know there's a lot of new people getting into woodworking. That's outstanding. It is a concern for me because a lot of people are venturing out, purchasing machines, and starting to use them without any background or training. I strongly encourage you to seek a mentor or sign up for a local class so that you can learn how to operate these machines safely. What's really scary is there's a lot of people that not only are brand new to woodworking, but they're recording videos and putting them out there on the internet for other people to pick up bad habits from them. Now, undoubtedly, I've shown you a few of my bad habits in past videos. My goal with this series was to reset myself and make sure that there's good information out there on not only the table saw, but other machines for those that are starting out on their own. And it's at least a starting point for an understanding in the basics of shop safety. And at least I can rest peacefully because I know that I've shared that information with you. Please check out the links below. Not only the components of the table saw that comes before this, but afterwards I will have links to the videos that I make about setups and different cuts on the table saw and other machine tools that are common in the shop. There's also a document that'll reiterate everything we went over and a little bit more in writing. And then there's some diagrams of the table saw components, and there's even a test that you can take as though you're getting ready to take a shop class to test yourself on your knowledge of the fundamentals of table saw safety. I'm going to continue to update that library of things for you to refresh on some of the fundamentals of safety and to share with new woodworkers if you happen to be in a mentorship type situation. The goal with this series is generally 3 parts. First, to give you an overview and understanding of the components and their functions on each type of machine. And then, similar to this video, to demonstrate the basic safety principles and some fundamentals for setting up and operating the machine safely. And then third or subsequent videos for each machine tool, we'll talk about specific operations and how to get the best results with your type of machine for different types of specific operations. With the table saw, cutting dados, miters, and grooves, or cutting sheet stock.